All right, day 10 coming up. And we have a grid. Uh, what is a trailhead? Starts one or more hiking trails. Okay, this is just some like grid BFS thing. Assume you can only like step one, exactly one. Okay. Ah, no. God. Very frustrating. Uh, Number of trails. Okay. Uh, yeah, it's too slow. Okay, so what was going on here? Um, so we're given this grid of numbers, and every position is 0 through 9. And we want to find, I guess, trails, paths, whatever, through the grid, where a path is just the numbers 0 through 9 in order, right? So 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure, that's a valid path. Uh, so in part 1, the question is, I guess, how many pairs of zeros and nines are there, where the 9 is reachable from the 0. Um, so I've like completely destroyed my part 1 solution in writing part 2. I wonder if there's a way to fix it. Seems like kind of different. Um, so maybe I'll just explain part 2 while I think about how to re-add part 1. So in part 2, we want to count how many paths there are from 0 to 9s rather than how many pairs of 0 to 9s there are. So what's the difference? Uh, Here's an example with only 1 0 and 1 9, so this would count only 1 for part 1. But it actually counts 3 for part 2 because we could branch off here, or we could branch off here, or we could branch off here. So there's 3 ways to get there, even though there's only one pair of start and end. So that's part 2. So what did I do for part 2? I did a dynamic programming solution, which is for every 9 in the grid, I'm going to count how many ways there are to reach that 9 from a 0. And we can do that recursively. So if we're at a 0, there's one way to reach the 0. Just start there. Otherwise, you can consider going sort of downhill in the 4 directions. So, go in some direction. If you get to a valid grid cell, and that grid cell is one less than you, then the number of ways that you get to your final destination is the number of ways to get to that destination. But that's a valid way, right? It's to go to that position first, and then take another step to my current cell. So that's a recursive solution. And we can memorize it, which is what this DP dictionary is doing, which makes it efficient. So that's a good solution to part 2. So then in part 1, we only care about pairs of zeros and nines. I'll just write a different function for this. This just seems like it wants to be a BFS. Something like this. 760 and 1764. Okay, cool. So that works. Sure, there's a nicer way to do this, but I just wrote a separate function. And as I said, this just does a BFS from this 9 cell. Counts how many 0 cells it can reach. So we keep track of the set of cells that we've seen. If we see a 0, mark it down. We know that we only see each cell once, so we're not going to double count. And then just try going in the 4 directions, and if you can go down from here, then go down. It might be nicer to not have to circle these int calls everywhere. Still work. It's not still work. What? No. Let me see. That's what I get for trying to make it better. Okay, cool. Okay, I think this code is reasonably clean. As I say, I don't see a good way to combine part 1 and 2. Maybe someone will tell me a good way, but I'm pretty happy with this. So that is all for today. See you tomorrow.